Hi, welcome back. If you're new, my name's Dave Thomas, also known as 7#9. And today we're going to be doing another video on the topic of Unity with F#, but we're going to be delving into a lot more 3D compared to the 2D videos I did with Monogame. We're going to be basically moving our character over a 3D world and also animating it with some collision detection and also adding gravity. So basically, player input, moving a character over a 3D world with animation. Hope you enjoy the video. First of all, we're going to go to the Mixamo site and we're going to grab some animations for our character for this video. We're going to do a search for mutant, just to find something that's a bit different. Now we need to grab an idle animation, so we're going to use this one. Click on the download button and we need to change the format to FBX for Unity and click download. All of these assets are going to be used to essentially animate the bones of our main character, so we're just literally getting some motion captured skeletons here. Now next we need a walking animation, so we're going to use the mutant walking one. Make sure you click in place. This makes sure that our animations are only animated from the center of the character rather than have any motion associated with them. Now just click download as we did before. Finally, we need a running animation. And I found that the running animation for the mutant is a little bit clunky. It's kind of like a bit stooped. So what we'll do is we'll just search for any other normal run animation. So if we choose this one, click in place, and that seems to look alright. It's kind of like an athletic running animation. And we click on download as usual, make sure FBX for Unity, and click download. Next we're going to go to the Unity asset store and we're going to search for a character called Jamo. It's a really nice robot character that's a free asset, so normally you just add the asset to your Unity assets. So this button here would normally say add to assets, so just click on that button to add it to your asset repository. Next we need something for our character to walk on, so we're going to search for block creator. And this is the asset here. So also click on Add to Assets. Now we're going to jump straight into Unity and we're going to add in something from the package manager. So pick my assets and pick the assets that we've just added to our assets. So here we click download for the block creator light. And then after that you would click import. We do exactly the same for the Jamo character. We click download and then we would click import. And we need to upgrade a package for this, so you just click install or upgrade. Wait for that to do its thing. And then we would also then click import to. And close the package manager. So you can see here we've got building blocks light. And we've got some prefabs added, which is basically some shapes that we can reuse. And if we go to Jamo character in the prefabs folder, there'll also be a Jamo player there as well. So if I enlarge this window, you can see the character that we've added. If we go to the building blocks, we can also do the same for those. You can kind of look at the different ones and see them in 3D. Let's close these for now. And the next thing we need is the new input system, which is an optional package. So if we go to the Unity repository and we have a quick look to see if we can find it, you can scroll down to find a package that you want, or you can actually search for it. So we'll type in input system, you can find it here, version 1.3. And we click install to add that. And close the package manager. Now Unity has several different input systems. This new modern one is slightly more flexible, so it's kind of prudent to use the new one as this is a brand new tutorial. It is a little bit more fiddly to set up, but as I said, it's more flexible, so it makes sense to use that here. Okay, next step, we're going to create a brand new folder called animations, and we're going to drag the animations that we previously downloaded into this folder so that Unity can use them. So select our animations, drag them into the animations folder, and Unity will import them in. Now if we click on one of them, we need to do a couple of changes to make this suitable for our character. We select the rig type to humanoid and click apply. And we do that for each of the animations. So click on rig and then change that from generic to humanoid, click apply, and finally do that on the last one too. So to make that clear, we're changing the rig's animation type from generic to humanoid. The character we downloaded has a humanoid type rig, so we're just making it match. What I'd like to do now is update Unity to the latest version. Earlier on, you might have noticed that one of the packages was displaying a warning that we're using a preview version of the package. Now that package is not preview in the current version of Unity, so let's go to the Unity Hub and update our project to the latest version of Unity. First of all, select the edit version, then select the latest version here, click open, and then click change version. Now things will wear around and we'll update with the latest version of the Unity editor. Next step we're going to do is we're going to find the general character and we're going to drag it into our scene. Just rename this to player. And let's also add a directional light to our scene. Make sure that's at the end. Change off 2D view and you can see our character kind of looks a little bit dark. I think we're missing some environmental lighting. So let's go down to the rendering lighting section, click on environment, and let's add a skybox material. So scroll down, select the default skybox. And let's add the directional light as the sun source. And then for the source of the environmental lighting, we'll choose the skybox as well. I think that's all the settings here. So close that. And if we rotate our view, you should be able to see that everything looks pretty nice now. There's a nice shine on the character. Let's center off our player in the world. And let's start adding some environment to our scene. Let's add one of the large 16 by 16 to the scene, and if you double click that in the scene, it centers it in the view. We'll just center this off in our world again to 0 coordinates. And let's raise our player up in the air a bit, otherwise he's inside the scene. And let's drag another few different types of elements into the scene. Now let's speed things up while I move things into the scene a little bit. Right, so we've got a nice little scene now. So if we set our selection to the main camera and then view out to the game scene, we can now set up our camera up to look at kind of like our default view in the game. This will be fixed for now, but we can make this move about in the future. So I'm just going to change a couple of the settings just to make it look visually appealing just for this little demo. Get the direction the right way around. Kind of just get things looking slightly down on a player. Maybe it's like a 20 to 30 degree angle downwards. And that's it. Next thing we're going to do is set up the input system. So we're going to go to create and then input actions. And we'll call this PlayerInput. So you can normally generate a C# class, but we're not going to do that. Click on the edit asset button and we'll add a new action map and we'll call it character controls. We can add a new action and let's call this move. And for this action, it's going to be a simple value, and it's going to be a vector 2. In the processor section, let's add a normalized vector 2. This is to make sure that the diagonals do not go faster than the up, down, left, or right. So now we need to add a binding. So open up Move, click on Node Binding, and click on the path and type in left stick and select Gamepad. Now we need to add another binding, but we'll use the composite one. This allows us to use different keys for the up, down, or left or right to make up the vector 2. So click on the up binding, click on the path and listen, and select W. Do the same for down, but pick the down key, which would be the S. Do the same for left, pick the left key. And finally, the same on the right key. Let's add another action, and we call this Run. Now this is going to be a simple action, which is just going to be a button, so we'll leave that it is. But if you can click on the node binding, click the path, click listen, and then we'll type in the left shoulder key for the generic gamepad. So just left shoulder. Add another binding in, and we'll add a simple binding, click listen, and we'll just press our left shift. So save asset. So in summary, we've got character controls, which encompass a move action, which is controlled by the left stick, and also up, down, left, right from the keyboard, and a run action, which is controlled by left shoulder and the left shift on the keyboard. So we can close this now. Now let's start setting up our player. So if you're looking at character controller, we've got some extra scripts here. If you click remove component, they become disabled, which isn't ideal. I prefer things to be a bit cleaner. This is because this is set up as a prefab. So if we delete our player and start again with this section, if we go to let's have a look. In the Jammo character, there'll be a normal model. So we've got a Jammo low poly model here. And this one doesn't have any scripts or anything on it, so we can kind of start from scratch and add only what we need to. So first of all, let's reset him back to the Y position of 3, so he's above the world. And if we look for a character controller, we'll add one of those in. This is basically a controller which lets you move about the character in different ways, and it will interact with the world. And it's a really good starting place for controlling a basic character. If you need anything advanced, obviously you'd have to make your own, but it's a really good starting point. And now if we look at this capsule, which you can see overlaid, this is actually the collider for our player. So I'm just going to tweak some of the settings so the collider is kind of like in the boundary of the main body of the player. Not too high, not too low. If it's not set correctly, your player will actually sink into the floor a little bit, so it's important to get the capsule lined up correctly with the feet and head really. That looks good to me. So now we'll add a player input, which allows us to use the script that we defined earlier on. So if we look at the player input, we can actually select the asset that we saved earlier on. So now this component allows us to consume that asset. And it will also let you interact with a camera, but this is mainly used for like split screen views and things like that. I think that's everything we need to set up for now. If you look at this step offset here, this is actually the distance that allows us to jump up a step in the world. So that's kind of set for about right, because we set it to 0.25 earlier on. And I think that's everything set up. Okay, so one thing we forgot to do is to change the player so that his rig type is humanoid. If we didn't do this, then it would cause the animation not to be rendered correctly because the bones would be configured differently. So what we're going to do now is we're going to create an animation controller. This allows us to consume the different animation scripts with effectively a state machine. So we'll create one of those, click open, and we're going to add some states to this. So we'll create an empty one for now, and we'll rename this to idle. And we'll select the animation that we added earlier on, which is the mutant idle one. Let's create another one for our walking. So I'll rename this to walk. Create another one for the run state. Let's type in run here. And now we'll add some transitions. So we'll make a transition from idle to walk, and then a transition to walk to run, and then one from walk to idle. So for our walk state, we'll add our walk animation, which is the mutant walking one. And the same for the run. We'll select our running one, which is the running near the bottom. Now the next thing, on our transitions, we need something in the condition to make the transition happen. So we'll go to the parameters and add a new Boolean parameter, and we'll call this isWalking. We'll create another one, and this is exactly the same, but this is for the running state, so we'll call this isRunning. So on the transition, we add the condition, we pick isWalking, and we set the value to true. For the walk to run transition, we set isRunning to true. And on the way back from run to walk, we set a condition called isRunning, set that to false. And then from walk to run, we set another condition where the isWalking is set to false. So in summary, we've got idle, which transitions to walk if isWalking is true, and it transitions from walk to run if running is true, and from run it transitions back to walk if isRunning is false, and transitions from walk to idle if isWalking is set to false. The other thing that we should check is to make sure that our animations have this loop time clicked, because if we don't, the animation will only play once, which isn't very good for walking because it's a continuous cycle. So make sure that all three of those animations have the loop time clicked. What I need to do now is select our player and make sure that the animation controller that we just built is assigned to our player. So if we go to our scene view now and look at it in 3D mode, we should be able to switch into game mode and see how things are progressing because we've actually assigned the animation controller. So now if you rotate around in the scene view while the game's running, you can see that our idle animation is now playing. And if we look at the animation inspector, you can see that the states are progressing. What you'll also notice that the complete animation cycle has to finish before it transitions to another stage, and this makes transitioning from things like idle and walking really unnatural, because when you transition from one phase to another, you kind of want it to be immediate. So let's try and fix that now. So we need to go back to our assets and select our character animation controller, and if we select the actual transition phase, there'll be a property called hasExitTime. And we want to remove that because we want our states to transition immediately. So on each of the transitions, remove the hasExitTime, and this will allow our animations to move from one stage to another without actually waiting for the animation to exit. So if we hit run again and go to our scene, if we click on the animator, if we click isWalking and then quickly select isRunning, you can see that the transitions happen instantaneously. If I drag our animator off to the side, we should be able to see this as it happens. So we're in idle, we're walking, and now we're running, and everything is instantaneous. So let's stop that, and I'll drag the animator back over here just so everything's back to normal. So with that, I think we've set up everything we need to so that we can now consume all this with our F# script. So here we are back with the script that we started last time. Let's open up the project file now. So first of all, what we're going to do is add in a few references that we need to start the project. First of all, we've got this new input system, which is just inside the script assemblies directory because it's an included package. Next, we have the animation module, which is actually inside the Unity editor directory itself, much like we selected last time. Then we've got the physics module, which I believe this is for the character controller. This is also inside the Unity app package. And that's all the references we need here. So let's jump back to the code, and what we'll do is we'll remove all of the old code we did last time. And first of all, we'll open up a new namespace, the Unity Engine Input System, and we'll create a brand new type called Animation Movement Controller, and we'll just inherit the basic mono behavior for a standard Unity type. The first thing we're going to do is create a whole bunch of mutable bindings, a player input to control the player input controls we created previously, an animator to control the animation, character controller to control the character. We'll create some action maps, which are the actions we created as part of the player input, and we'll also have a reference to the main camera. So let's define a bunch more of these. We'll create a move and a run, which are going to be actions to capture when move and run happens from our input controller. We'll create a current movement input, which will capture the vector2 from that movement. And we'll create a current movement, which will be a vector in 3D space that we're going to apply to the character controller. Movement pressed, which is whether movement actually occurs, and run pressed, which is actually if the run button has been pressed. Now, in order to bind all of our objects that we declared above, we use the awake method. So in this method, we grab the player input via getComponent player input. We grab an animator using the animator. We do the same with the character controller, and we do the same with the main camera. For the character controls, we use the previously bound player input actions, but then we call the findActionMap method, passing in the character controls which we created in our player input. And we also then use that to grab our move action and our run action by using the findAction methods on the character controls, passing in move and run that we declared when we created our actions. I'll just collapse the Explorer so we've got a bit more room on the screen. Now next we need to use the move action, but we need to use one of the event handlers, add. Now in F#, the event handlers, because these are non-standard, we have to use the add_started, which is actually what's defined under the hood of an event in C#. But we have to apply an action that we want to use for a callback. So I'll call it process move. And we'll actually define this function here. So we'll call it process move. It takes a context, which is an input action .callback context. So the first thing I'll do is we'll actually grab the current movement input from the context. So we just use read value vector2 for that. The next thing we do is we grab the current movement input.x and the current movement input.y, and we assign those to the current movement x and z fields because we're only moving about in the x and z planes in our world because the y is not used. Movement press is a Boolean value, so we set it to the result of whether the current input.x is not 0 or the current movement input.y is not 0. So we also had callbacks for whether move gets cancelled or when move gets performed, which is at the end of an update, like the release of a button. Next, we do exactly the same thing for run. So it's much the same, it's just a normal callback. So we need to basically create another callback function like we did for move, but for the run button. So we'll call this process run. And we'll add this just underneath process move. Again, it's the same syntax, it's a context, input action, callback context. And what we'll do is we'll read a value as a button, which just gives us a Boolean result. And just like for move, we add another callback for run that gets called on cancelled, so we can detect when our run button gets released. For the input system to work properly, it needs to be enabled and disabled, so we use the onEnable function to enable our character controls, and we use the onDisable function to disable the character controls. These members are called on the mono behavior when Unity enables and disables that particular mono behavior. What we need to do now is actually plug this into the update function. First of all, we create a let binding called movement, and if run is pressed, then we multiply the current movement by the run multiplier times by the time delta. Otherwise, on the else condition, we take current movement and multiply that by the walk multiplier times by the time delta. What this does, it gives us a movement vector which effectively increases the magnitude in the direction that the user's picked, so the run multiplier will be a higher number than the walk multiplier. So now we use the character controller move method to pass in this movement vector we just created. You'll notice we haven't actually created run multiplier or walk multiplier, so let's scroll up to the top and add these in. So our walk multiplier is a simple float 1.5 and the run multiplier is 4. Again, if run is pressed, then we use the run multiplier times by the time delta. If it's not, we use a walk multiplier times by the time delta. And we pass that straight into move. Now we need to build our project. Control, Option and B, and the project will now build. You can see there our assembly has been built. Let's close this window and switch over to Unity. So now everything's reloaded. We can click Add Component, go down to Script, and scroll to the bottom. It's just off the screen here, but it's the FS assembly. Then we can pick our new type, the Animation Movement Controller script. Hit play and we can see what happens. So you can see on the screen our player is not affected by gravity. It moves fast with the shift held down. Without the shift, you kind of move slowly. So everything's working as expected. Let's stop that and switch back into VS Code. So the first thing we'll need to do is let's add some gravity. We'll create a normal gravity of -9.8 and a grounded gravity of only -0.05. We use the grounded gravity when we're on the normal surfaces of our level, so it doesn't produce too much push through of our collision objects. It just makes the physics engine a lot more stable. Now we'll create another member called handle gravity, and we'll actually use the character controller's isGrounded property, and we'll set the current gravity to be equal the grounded gravity times by the time delta, and the current movement y to be the current gravity. If the character is not grounded, we set the current gravity to the gravity times by the time delta, and we also apply that to the current movement y. In this case though, we add it on so that it's a cumulative effect. So you get the effect of increasing velocity over time when you're falling through space. To plug this in, we simply add the handle gravity function to the beginning of the update. The next thing we're going to do is fix rotation so the player actually faces the direction that it's moving in. Here we'll just add rotations per frame, which is at the maximum amount that our character will rotate during each frame. And now we can add another member function called handle rotation, and we'll pass in the movement that occurred during this frame. And if a movement key is pressed, like we've got a direction that we're moving in, we create a vector 3 that represents that movement, so we're using the x value and the z value. We get the current transformation of the mono behavior, and we call that current rotation. Now we find the target rotation by using a quaternion look rotation, passing in the position we want to look at. Then we set the transform rotation to a quaternion slope between the current rotation and the target rotation, and the rotation per frame times by the time delta. This has the effect of slowly rotating from where you're facing to the new direction using the quaternion slope, which is a spherical linear interpolation between the two rotations. So let's refactor the update slightly. We're going to create a relative movement vector. This is almost the same as before. We're creating a let binding called movement, and if run pressed, then we use the run multiplier times by the time delta. Otherwise, we use the walk multiplier times by the time delta. But we'll use the quaternion.euler to transform our relative direction into the camera's viewport by using the Euler angles from the main camera's transform rotation, and we'll multiply that by the movement vector, which will give us our relative movement into the scene of the game. Now that we have our relative movement, we can pass this to the handle rotation method we wrote earlier. And we just refactor this to rename that to relative movement. Now we need two more bindings to represent isWalking key and the isRunning key. We use the animator string to hash function so that we can efficiently find these from the animator. Rather than using a string lookup, we can just use a hash lookup, which is a lot faster. I think the final member that we need to write here is for handle animation. First of all, we need to grab the isWalking animation from the animator, so we use animator getBool, passing the isWalking key and the isRunning key. Now we use a series of Boolean checks to set the correct animation. So first of all, if movement is pressed and this is not a walking animation, then we set the animator's Boolean for isWalking key to true. Else, if there's no movement pressed and the isWalking animation is true, then we set the Boolean for isWalking key to false. Now we switch to running. So if movement is pressed and run pressed and not isRunning animation, then we set the animator Boolean for isRunning key to true. And finally, if there's no movement pressed or there's no run pressed and isAnimation is true, we set the Boolean for isRunning key to false. So we first use the isWalking animation key to get our animation states from the animator. And if movement is pressed and there's no walking, we set the animator walking to true. Otherwise, if there's no movement and there is walking, we set the isWalking to false. But if movement is pressed and run pressed and there's no running, we set running animation to true. Otherwise, if there's no movement and no run pressed and no run animation, we set the isRunning to false. Now this is a fair number of if-else blocks. It's probably the limit of the complexity that you'd want to get into before you refactor to something like pattern matching or active patterns. But we can save that for a future video. So now we just need to plug this straight into the update function. So to recap, we first of all handle our animation, then we handle gravity, calculate our relative movement, we handle a rotation for that movement, then apply the movement to the character controller. I think that's it for everything here. Now we do another build, wait for that to complete, and switch back to Unity. So now we're back in Unity. Let's wait for everything to recompile, and let's hit the play button. So our character drops on the screen, we've got nice walking and animation. We've got running with run animation. Our character turns around whichever direction we choose to run in. And everything's looking quite good. Our character also moves off the steps seamlessly too. Let's run him over the edge, see what happens. Yep, he falls into the abyss. So if you made it this far, why not subscribe to the channel, watch another video, tell your friends about them, and I will see you in the next video.